All right, so this one says if g of x is f of 4 times x, which statement is true? Okay, so what we're doing, if I think about a table of values, and I'm assuming that f of x is x squared. This is what we're, whoops, wrong thing. This is what I want. Consider the table of values like this, right? So what I'm going to do is I'm not really going to plug the value. Well, I'm going to do a couple of them, and I want you to think about what's going on. So sketch this out. I have an x value here. Then I'm going to have f of x in here. And I'm assuming, because this is quadratic, that the parent function is f of x equals x squared. Right? And then I have g of x. So, and we're just gonna plug in like 3 numbers here. So we're gonna evaluate these functions at 0, 1, and 2. So f of 0 is 0 squared, right? Which is just 0. F of 1 is 1 squared, which is just 1. F of 2 is 2 squared, which is just 4. Now, when we evaluate the g of x, what we're going to do is we're going to take our x value and multiply it by 4. So g of x is just going to say g of x is really 4 times x. Right? So g of 4 times 0 is still 0 squared. So that's going to be 0. But g of 4 times 1 is 4, so that's 4 squared. So that's 16. G of 4 times 2, right, because I'm evaluating my x value, is 8 squared, so that's 64. So that changes things quickly. So what I need to do is I need to figure out which one of these, and we'll graph it real quick and see. But one of these, something's occurring to the graph. Now, if it's inside the parentheses, it's a horizontal stretch or compression. Okay? Now, it's the inverse of it. In other words, I believe it's C. We're going to compress horizontally by a factor of 1/4, right? And what that means is it's because the y values, because it grows faster, it's going to compress like this. So let me just plug it in the calculator, and then you can see what I'm talking about. So I've got my parent function already plugged in. Hit y equals this button right here. Oops, got a little happy there. Then I'm going to come down here. Now this is the important part. I'm going to graph 4 times x, and then hit the caret symbol here and raise that to the second power. All right. So what happens is, because I'm multiplying the x value by 4, it's going to grow faster. So it's going to be skinnier. So I'm compressing it to 1/4 of its size horizontally. Does that make sense? Because I'm multiplying by x, I'm going to get my y values much quicker than before. And so to just double check and make sure Mr. Adams did his math right, you hit second and hit the graph button. See this little thing that says table? That gives you the table of values. And as you can see, yeah, Mr. Adams did his math right. This one, when x equals 1, my y value for the parent function is 1, but it's 16 for g of x. For f of x, when x equals 2, y equals 4, right? Because that's 2 squared. But 4 times 2 equals 8 squared, which is 64. So because I'm taking this number and multiplying it by 4 and evaluating it, it grows a lot quicker. So I'm compressing it by 1/4. Okay. And you know what I should probably do? Let's take a screenshot of this and we'll incorporate that into our notes just to have it there so you can see what's going on. Okay. And let me zoom out so you guys can see it all. And again, the blue function is going to be my f of x, which is x squared. And then my purple function is going to be g of x, which is equal to f of 4 times x. Okay?